Hello everyone, welcome to my talk about Selenium capabilities. I was hoping for 10 people, but 100 is good enough. Um, my name is Adi. I'm an kind of an old developer with 20 years of experience. My day-to-day job is an architect for a platform that is called Mobile Center, and it's like an enterprise Appium. And a lot of my day-to-day job is working with SDKs, APIs, and specifically with Appium. So I just love WebDrive. WebDrive is one of the most commonly used automation APIs, and great thanks to Stuart, who created WebDrive 10 years ago. So in this talk, I'm gonna focus a lot about test configuration and about the advanced configuration that we can get. When WebDrive was created, it focused a lot about test functionality and how can I configure my tests, select my browsers. But it left open the way for vendors to implement their own grids and functionality, which is very advanced. In this talk, I would like to focus specifically on those um, advanced capabilities of vendors. But why should you care about vendors, right? Vendors can bring you a lot of advanced functionality that it's hard to get to it by yourself. And later on, I'd like to talk about if you choose to use vendors, how can you refactor your testing code and your testing framework that you won't get locked in into vendor implementation? Okay. So in this talk, we're gonna talk about mobile capabilities, specifically Appium and around it. We'll talk about network emulation and why is it important in functional testing. We talk about coverage and matrix testing. Later on, I'm gonna explain why you should avoid vendor lock-in and how can you avoid it. And eventually, I'd like to give a little example of how we changed a little bit the open source for our needs and to give you a taste how you can do it too without being afraid of changing open source. So first, let's talk about mobile capabilities. Who here uses Appium or mobile testing? Not a lot. So I'll explain briefly what is Appium. Appium is a WebDrive and the Selenium SDK. They took the same thing and just enhanced it a little bit, add a little bit of API for mobile testing. So you take the same Selenium API that you have a lot of client libraries, you know Selenium, right? And you still do find by element and get back a web element. It's kind of weird. You get a web element, but it's on a mobile, and not only web testing, but also native application testing. Okay? So you have the same API to find elements by ID, by name, whatever you already know, and a little bit of extra functionality like swipe and stuff like that. So you have the client libraries, you have the same REST API enhanced a little bit with some additional REST APIs, and then the Appium server, which is written in Node.js, which instead of using Firefox driver or Chrome driver manipulates UI automation and UI automator for manipulating mobiles. Okay? So, as a tester, from your point of view, you have an API that you know before, and now you can automate mobile testing. Let's see an example of how does it look like. For starters, you're gonna say which platform you wanna use. In this example, I'm using Android. Next, you're gonna say, I want to open up this application, okay? Instead of browser with a URL, now you're gonna say which package you wanna start. And later on, you're gonna say, please start this activity. So you'll open up the relevant view within this application. And next, and that's the first enterprise or vendor-based capability. You can see a vendor that implemented username and password. Why is it important? When you tested on a browser, was fun. Yeah, you had it on your desktop, and now you need physical device, right? And when teams get larger and larger, they need more devices and different devices, and you find themselves running between each other and exchanging devices. And as the team goes larger, you finally build a grid, place a lot of mobiles on racks, and start sharing a lab with one another, right? But when you start sharing a lab and one another, and start firing up your test against this grid, things start colliding, right? Everyone start using a device. You don't know who took a device, who's using it right now. So username and password, a great way to say I'm using this device, right? I'm locking it for my usage. And if you are using a device in the cloud, of course, it's repeat itself. You need to say who you are so the vendor can charge you by the minute on the device you are using. Next, in Appium, you're saying, I want to use this specific device. That's the unique ID of a certain device. But that's a little bit limiting, right? We saw cases where the device got broken or heated and we wanted to replace it. Now if we replace it, the ID was changed, but the test is not changing, right? So you really want to say, I want to use, for example, Samsung S6 and not use a specific ID of a specific device. And with Appium, you can say, I want to use a certain OS version of a certain operating system. Like I want to use a mobile with 7.0 version. But that's also limiting. What you really want to say is, give me any Android. If I remove the UDID and I remove the device name, give me any Android that answer my capabilities. I want to use any device. This is 7 and up, okay? So tomorrow, when it will be 7.01, my test is not broken, okay? And this, the vendor can help you with these specific capabilities. And last, this is the standard Appium, and it's almost the same with remote web drive, like Android driver inherits from remote web drive. You just fire up where is Appium or the grid of the lab and give it the capabilities. Okay, let's talk about network emulation and why is it good for. So in browser space and desktop space, this is easy. You have a desktop or a computer in the lab that is connected to a LAN or a good Wi-Fi. That's not the case of your users. And you are doing functional testing, but the world is different. People are using your Uber application on the road. You're using your banking application in their taxi. They are using it in places with bad reception. They are using it when they are skiing. They are using it in different situations, moving fast, moving slow in an elevator. And as it turns out, a very weak connection could lead to up to 1000 times slower application than usual. It's not only loading the data, the behavior starts changing. So vendor give you the ability to create a network emulation. I want to use 4G or 3G or Wi-Fi or something really bad. I want to say where is the user? Maybe he's in Japan. Okay. And network emulation can help you with that. So a good capability is saying to the network emulation, just network profile having 3G good and later on maybe 3G bad. Okay. So let's talk about the metrics. You're testing your functional testing on your desktop, right? With your Chrome or your Firefox. Can you change the IE version? Every version that you're missing potential customers, right? And there are a lot of OSs too. Can you have the full metrics of all the operating systems and browsers? It's a difficult task. With mobiles, it's even crazier. There are 20,000 kind of devices of Android, and there are like 70 iOS kind of devices. And this is only type of devices and vendors. You also have versions of the OS, which is changing all the time. If you put an iOS in the lab, every 2 weeks, Apple will release a new minor version. Your users will adopt it very fast, and you're out of capacity. You're not running after your users. And it's an ongoing job all the time. So now we have the following problems. One is expressing a very large matrix of testing. And the second is doing the matrix, the actual operation. It's not functional testing, it's not your work, but it became your work. You have to test all the browsers on all the OSs and a lot of mobiles. What about screen resolutions? Are you checking all the screen resolutions? That's a lot of work. Doing it all by yourself, all of you, is kind of hard. So that's where vendors come in. And here is an example for expressing the matrix by a vendor. This example is a browser stack runner that it's an open source. You can use it with browser stack. And they express a certain kind, it looks like capabilities, but it's not. It's similar. They're saying Chrome previous, Chrome latest, and you can use it. And you can even go deeper and say specific browser, specific OS, and use it in your tests. Another kind of solution is Amazon Device Farm, which is very nice. It's an amazing solution. You create a pool of devices that you want to test on. You upload all of your tests as a one suite of tests. You upload your application, and then you fire all of this grid on all of these tests. Sorry. So it's a great solution. Amazon is a partner of us, and I really like this solution, but it's completely proprietary. If you want to change solution later, you have to do something else from scratch. Not your test, but your whole grid solution, your whole configuration. And it's not capability driven. Yeah, they're saying create a pool in our UI, in our CLI, and run your tests. So there's burst and there's test as a service. We saw earlier browser stack, and you saw example that the test is running in your lab or on your computer, and the test is firing commands to the cloud. That's burst. There's test as a service. That's Amazon. You upload everything to there. It's running there. The test runs there. The mobile is there. Everything is there. It's test as a service. The difference is, and you need to understand the trade-offs. I'm not saying there's something good or something bad, but you need to understand what you're doing. Different is that with burst solution, you can control the test flow. If you're running and a certain device suddenly disappear in the cloud, that could happen. You want to rerun the test on these devices. The test didn't fail, the device failed. Okay? So you can embrace something like the runner that I showed you earlier at the first day and have a solution really quick, and later on switch and build your own little framework that does the burst. With test as a service, you can't do that, right? You can't come later and change the mechanism. And also, the vendor decides where the session starts and where the session ends. You expect to get all the tests, and that's it. If it fails at test number 7, he has a certain logic to it, and that's it. Another thing to consider is that burst. If the test is running from your lab to the cloud, it's very slow. There's a latency for every step from your computer. Yeah, you find an element on a mobile that's in the cloud. There's a huge latency. Unlike test as a service, everything is running near the mobile. Another thing is, because of this latency, is considering the timeouts. The same tests that you run, you'll probably run them locally, right? You have something for every push or commit or pull request. Yeah, that runs 10 minutes. You don't need the cloud for that. But maybe you want to run end-to-end tests with the cloud. Yeah, so same test, run different places. So you want to change the timeout between vendor implementation, even if you're one of the vendors, right? If you're running it locally or remotely. And let's talk about bridge, cloud bridge. So you decided to use a cloud vendor. Whether your test is running locally or in the cloud, now the browser itself or the mobile is in the cloud. But a lot of the time, you're testing an application that is connecting to a server that is not public. Yeah, your production is public sometimes, sometimes not public, but your staging, QA, dev, everything is local. How do you get inside the IT network? That's complicated. So there is a solution across vendors. Each vendor has its own. It's called a bridge, a cloud bridge. You install something locally, which goes out to the cloud, and then there is an open connection, and then your browser or mobile is configured as a proxy to go through the bridge. and access your server. That's something that vendors give you. For example, you can see a utility that you run. That's the client bridge. Yeah, you run it from command line, you give it an access key, and you tell it that's a tunnel that is called test123. When you want to run the test through this tunnel and through this bridge, you say as a capability a specific name of the vendor. You see something very proprietary, browser stack dot local identifier, and the name of the tunnel. Now they automatically route your calls through this tunnel, through this utility, and the endpoint is your server, which is inside the IT network. So this is very proprietary, but with great value. Now you don't need a VPN, you don't open up your firewall. It's a utility that helps you reach your server. But a good thing to remember is when you try things like that, to do your security due diligence, not let the IT guys chase you, because you're kind of opening a little hole in the firewall. Okay? An open source example that you can use, which is also proprietary, but it could be your solution, is an open source that's called ngrok. It has both endpoints. You can install something locally, you can install something in the cloud, and then you have a bridge, which is open source. And if you change vendor, this solution stays. Okay. So how can we use all of this magic, if we choose to use it, but not having a lock-in for a certain vendor? If we want to change tomorrow to another vendor, what's the design that we can take to go there? So first of all, we said we want to express the big matrix, right? We can set up a JSON or whatever format that you choose, which is structured, and describe the capabilities that we want to use for each item in the matrix. Okay? It could be for browser, for mobiles. There's a multiply here with the network profile that we talked about. You need to decide what you're going to run and how to multiply it with also different network profile, and maybe also screen resolutions. Something that you can, of course, use, and probably most of you do, is create a session factory that can help you decide what are the session boundaries. When is a session created and when it's destroyed? Why is it good for? If you use a mobile from the cloud and you have few tests, you don't want after each test to release it to the cloud vendor and then request another one, wait for 1.5 minutes, 2 minutes between each test. Even for a browser, you can create a factory that when you ask for a new browser, in the second test, just closes up the relevant tabs, reroute to Google or something like that, and continue fresh if you want. So when test is finished, it returns to the pool, and the session factory can give it to another test. So here's the design for avoiding vendor lock-in. We have the test on on the right, connecting a driver factory or a session factory, whatever you choose to call it. It has a getDriver method, and every time it does, it checks if it already has this capability that you are asking for, and it saves it internally, doesn't release it. And every time you call getDriver, it will return something that was already initiated. Its internal implementation can use a vendor, which is an interface, which implement all of the things we talked about before, right? Networking, credentials, bridge, timeouts, okay? Later on, when you switch vendor, you can have just a simple implementation of the same thing with another vendor, which could be you yourself when you use a local lab. So here is a code example. We have a vendor here which accepts certain capabilities and implement, for example, credentials is a certain type of user password. For setting a timeout, it uses a specific amount of timeout for this vendor. For getting a bridge, it will be certain capabilities and names for this vendor. And it changes between vendors the name of the capabilities. When we are creating the session itself, we call the vendor implementation without knowing what it is, and getting the credentials, the bridge, and creating the remote web drive, setting the timeout. Then we can return this new session and putting it internally inside a map that understand which capability we are asking and which driver to return. And the function that gets the session to your test calls this map, check if you already initiated such a driver for such capabilities. If you don't have it, it calls the previous function that we saw. If it already has it, it will return to the test. Okay. So I want to talk about an example of an implementation change that we did to the open source. There was no point in contributing it back because it was something very special to us. Nothing to help the general community, but it's an example of how you can change little points in the open source, but get a lot of flexibility. So WebDriver is stateful, right? We saw it, you create a remote web drive or Android driver with specific URL. It will always get there. The create session goes to this URL, and then all the calls will go to this URL, right? The find element, the click, the close, all the calls will go to the same URL. But we had a lot of customers that has multiple data centers, right? They have a grid, for example, in the EU. They have a lab in the EU, but they have also a lab in Asia. Okay, they have tester in Asia, and they have 2 labs, mobiles in both labs. And the tester wants to get a browser or a mobile from somewhere close to him. If he can't find a specific model that he needs or the specific capabilities, it will go to the further lab because he wants the shorter latency. He wants to get something closer and wants to work with the VNC with a device that is closer. And it's very limiting that WebDrive is stateful. It goes always to the same place. So what we did is modify the grid open source a little bit. We want to support a new capability called region and return a header so it will not affect the actual protocol that tells the client where is the actual device to connect to. So here is the problem. I have a test that wants to connect to a grid, but actually want to go to Asia mobile. How can it do that? Because with current implementation, every call will go to the grid and then to Asia and back. You get double latency. So it looks complicated, but really it's like 6 lines of code. We took the grid implementation of Selenium. It's Java, it's not so complicated. And in create session, we just added a new capability called region. In there, we understand there are more than one lab. Okay, so if we see a region Asia, we know first to look at the devices that are in Asia. Okay, and then if it exists, we call create session to the lab there, initialize the device ticket, return it to the grid, and then the grid return another header, a simple HTTP header that says where is the IP of this mobile or browser. And then we wrote a little gateway, a very small Node.js program that accepts this, that everything goes through it, and it knows that create session and close session goes to the grid, and the other calls go to the IP that we returned. So we know to split calls. It's quite simple. These calls go to the grid, other calls go directly to devices. And then if you are in Asia and using a gateway in Asia, then only the create session goes to the EU, and then all the other calls are local. So let's summarize. Before you start with mobile and grid solutions, think about the long term, because it's not so easy as you think. It's not only functional testing. Users are not in the lab. They are not working under lab conditions. So you need to think how you will emulate all of these things. Another thing to consider is using vendors for some use cases. I know it costs money and everyone loves open source, but some cases can save you a lot of time using vendors. Third, if you're gonna use a vendor, just with a few classes and a few interfaces, abstract the relevant vendor. Okay? So you won't get a lock-in if you change it. And then you can even use your own implementation for local test, for a pull request, and end-to-end will go to the vendor. And the last point is open source is open for a reason. Not just for consumption as free, but also as open code and not so complicated. If you need something, think of out of the box. Try to find how you can make little changes that helps you reach your goals.